Alright, 5.2 sum and difference formula. Let's give it a little title here. There we go. What's in black here is the formula. Note, this is more for when we have a sine, cosine, or tangent that's not on a unit circle. We use sum and difference formula in order to help solve that. Notice here that when this is plus, you're subtracting these two. And when you're subtracting two values, you're going to be actually adding. So for example, cosine of 105. There are multiple ways you can go about this, whether it's subtraction or addition, depending on what you are more comfortable with and what you find to work. In this case, two numbers that add up to get 105 that are on your unit circle. I'm going to say 60 and 45 degrees. And then we plug that in everywhere. Cosine of 60, cosine of 45, minus, remember it flips, sine 60, sine 45. Cosine of 60 degrees is 1/2. Cosine of 45 degrees is root 2 over 2. Minus root 3 over 2 times root 2 over 2. And that's going to get us root 2 over 4 minus root 6 over 4, which is just going to get root 2 minus root 6 over 4. There we go. And that is a solution. Now here's the sum and difference for sine. And go ahead and I would pause and write this down as well. The sines do not flip in this one, but sine and cosine sure does. Okay, so we have sine of 45 degrees. Let's think here. Two values that add to get 75. Let's say 45 and 30. We're adding again. 45 plus 30. And so it's going to get us sine 45 times cosine 30 plus cosine 45 sine 30. Sine 45 is root 2 over 2. Cosine of 30 is root 3 over 2 plus root 2 over 2 times 1/2. Giving us root 6 over 4 plus root 2 over 4, which is just going to get us root 6 plus root 2 over 4. There we go. So very similar process to the sum and difference cosine, just a slightly different formula. So we have a little proof here. Cosine of the quantity x minus pi over 2 is equal to sine x. So we need to prove it. Of course, we're going to use the sum and difference formula because we have x minus pi over 2. So in this case, we're going to have cosine x times cosine pi over 2 plus sine x times sine pi over 2 equals sine x. Cosine pi over 2 is 0. So this whole thing is going to be 0 times cosine x, which is 0. And then sine of pi over 2 is 1. So it'll be sine x times 1. Anything times 1 is itself. So this left side is going to go to sine x, which proving it true. Another prove it problem. So it looks like we're going to have to use the sum formula for sine. So sine 90 times cosine theta plus cosine 90 degrees times sine theta. Sine 90 is 1. 1 times cosine will just be cosine. And then cosine of 90 is 0. And 0 times anything is 0. So therefore, we're going to get cosine theta on the left, which will make it equal to the right, which is exactly what we were hoping for. Very nice. And here, right here, is we have the sum and difference for tangent. Very different than the other two. A little bit more to it as well. As you notice, we're adding two values for tangent. Whatever the sign is here will be the same as the sign here, but in the denominator down here, it will be flipped. Okay, so we got an example here with radians. So what two values can we add or subtract to get 7 pi over 12? Kind of have to work backwards a little bit here. So I'm thinking 4 plus 3 is 7. And that reaches down to pi over 3 and pi over 4. So it'll be tan of pi over 3 plus pi over 4. And it's going to get us tan of pi over 3 plus tan pi over 4 over 1 minus tan pi over 3 tan pi over 4. Tangent of pi over 3 is root 3. Tan of pi over 4 is just 1. 1 minus tan of pi over 3 is, once again, root 3 times 1. Giving us root 3 plus 1 over 1 minus root 3. Now, of course, we need to rationalize, so we're going to multiply the top and the bottom by complex conjugate denominator. So multiply the top and bottom by 1 plus root 3. And FOIL the denominator, that's going to get us 1 minus 3, which is going to be negative 2. And a numerator of 1 plus 3 plus 2 root 3. So it's going to be 4 plus 2 root 3. Divide both of them by negative 2. It's going to be negative 2 minus root 3 as your final answer. All right, I appreciate you watching, and we'll see you later.